we will look at adding and subtracting radicals. To add and subtract radicals, you have to simplify each radical if necessary. Because at first, they won't look like they can add together, but always simplify. So then we're going to add or subtract like terms. Remember, the last names have to match. So the last names have to match, which means that the index must be the same. And the radicand, or the number under the radical, must be the same. Because if the index and the radicand are not the same, then they are not like terms. It's almost like having x squared and x. They're not the same term. Or even x squared and a y squared, they're not the same because they're different variables. So similar aspects on this. And then 3, you're going to add or subtract the coefficients, which would be the like terms. Coefficients, and keep the radical the same. So similar to the variables where we have the same last name. So examples: 4 fifth root of 2 plus 3 fifth root of 2. Here we have a 4 times fifth root of 2, 3 times the fifth root of 2. So think of this as 4x plus 3x, where these two are the exact same name. So 3 plus 4 is 7, and then we have to keep the radical the same. So think of this as the variables. 2 square root 12 minus 3 square root 48 plus 3 square root 3. At first, this does not look like we can add and subtract radicals, but what we need to do is simplify. Make sure that our radical is simplified. So we have 4 and 2, or 4 and 3, excuse me. 4 and 3, 2 and 2, it takes 2 to break 1 out of jail. So this 2 will combine with that 2, so 2 times 2 is 4, square root 3 is left, 48, that would be 12 and 4, 12 would be 3 and 4, there's a pair of 4s, you can combine that with a 3, so 4 times 3 is 12, so we have negative 12 square root 3, and then the last one's just 3 square root 3. So now we can add across. Our last name is square root 3, and we are going to add the numbers. 4, 5, 6, 7 minus 2, that's going to be a negative 5 square root 3. Cubed root 16 minus cubed root 54 plus cubed root 24. So again, at first glance, they do not look like they can combine, but further detail, let's see here. 16 is 4 2's. 1 2 comes out, 1 2 stays in. For 54, that's 9 and 6, 3 and 3, 3 and 2, we have 3 3's. That comes out, and the 2 stays. That negative just came from the negative 1 we essentially have there. And then 24 is 12 and 2, 6 and 2, 3 and 2. We have a group of 3 2's, so 1 2 comes out, and a square root of 3 stays in. So as we can see, cube root 2's are the same here. We add them together and we get negative 1 cube root 2. Excuse me. And then this last one stays the same because we have nothing to add it to. You can rearrange these if you would like to say 2 cube root 3 minus 3, or cube root 2 if you would like. It doesn't matter. But I always like to make sure, well, since this was negative, I'll put it at the back. I do that so my negative doesn't get lost. And then we have, let's see here, square root 25 yz squared plus square root 9 yz squared, and then plus cubed root x y to the third. No, I went to the fourth, sorry. Here. There. Okay, that's x to the third, y to the fourth. Cubed root x to the third, y to the fourth. So now let's simplify. Square root of 25 is 5. The z comes out, we're left with square root y. Square root 9 is 3. We have a z that comes out, y that stays. And then we have the third root of, actually we don't have the third root of yet. We have x, y, cubed root y. Okay. There are 3 x's, 1 x comes out, there's 3 y's, 3 y's, so 1 y can come out, and then the extra y stays in. So yes, they look the same, but our index has to be the same. And also, if you look, zy squared, this is not zy squared, so that's a term in itself. 5 plus 3 is 8. And then we have z square root y plus x y cubed root y. Okay, so make sure the index and also the other variables you have. So it's not just the square root, you have to watch out for your variables too. Last one, cubed root 8xy plus cubed root 27xy cubed, and negative 3 x to the fourth, y to the fourth. Okay, so they're all in terms of cubed roots. So if the variables and the square root come out to be the same, then we can add them all together. So the cubed root of 8 is 2, and then we're left with cubed root of xy. Cubed root of 27 is 3. We have 1 y that comes out, and then we have a square root of, or cubed root of x. And then here we'll have a negative xy with a cubed root of xy staying in. Now, none of these are like terms. Ignore the numbers for now, and let's look at what we have. We have cubed root xy. Well, we have a cubed root xy here, but we don't have an xy in front of this one. So make sure that the whole last name matches. And that's the items that are behind your number or your coefficient. So y cubed root x has a different last name. So this would be simplified then. That's all you could do. And this concludes this video.